Alright, so the first thing, if we have x is greater than or equal to 1, Garrett, what type of line would be a line that's in x equals form? Horizontal?
Oh wait, no.
Vertical, yeah. So we're going to go to where x is equal to 1. That's a vertical line. Greater than means we should be shading in the right direction, towards the right. And then, Garrett, if you have y is greater than or equal to 3, that's your horizontal line. So going up to 3 and making a horizontal line. And that is also greater than or equal to. So right now, my solution is going to be right here. I can already see like the two lines kind of created a solution for us to be in the upper quadrant. The last piece, we have 2x plus 4y is less than or equal to 20. So, Holly, if we solve for y there, what did you get when you solved for y?
Y is less than or equal to -1/2 x.
Nice. Plus 5. So the third inequality, y is less than or equal to -1/2 x plus 5, takes us up 5. And then -1/2 means down 1 to the right 2. And we end up with this teeny tiny little shape. Any questions on finding that graph? So the next part says to find the max and min. In order to do that, we need to list what the vertices are. And there should be 3 of them since we have a triangle. Abby, can you give me any of the vertices that you found?
0, 5.
Okay, so not quite because it starts at 1. So we have to be to the right of 0.
1, 5.
Let's skip that one. Can you give me this one down here? Okay, so we have 1, 3, and yeah, that one looks like 4, 3. 1, 4, up 3. So that's 4, 3. This top one, though, right here, kind of crosses in the center of a box, not actually in the corner of the box, because this point up here is at 0, 5, as Abby said, but then you're going down 1 and right 2. And so when you draw your line, it's not connecting actually in a corner, it's going through the middle of a box. How can you find out where this intersects when it goes through the middle of a box and not an exact corner of a box? How can you find what that point is? Julia?
Do you put that x value into something?
Exactly. So we know that this line right here is x is greater than or equal to 1. But that line is actually x equals 1. So when x is equal to 1, we want to find out what this y value is when the line crosses through it. So using this equation, you can solve for that third point by plugging your x value of 1 into the problem. Because again, it doesn't connect in the corner of a box. It's not a nice, neat location for them to connect. So when it goes through the center, we can find that intersection by using the x value of the 1 line, because it's a vertical line, and then plugging that into the diagonal line that it intersects with. And when we do that, Julia, we get, yeah, so you could say 4.5, you could say 9/2. Either one of those are fine. But -1/2 plus 5 is 4.5. So that final location is 1 and then 4.5. Because it's going through the center of the box, not at a corner of a box. And again, you can just find that by taking the x value, plugging it into the line that's crossing over it. So then the last part of this, I'm going to move this junk here so I can get it out of the way. Doesn't all want to move together. The last part of the question, we'll just erase the y. Wants us to find the objective quantity, or the quantity that gives us a max value. And that equation that we're using is the C equals 15x plus 10y. So you're going to take your ordered pair, 15 times 1 plus 10 times 4.5. 15 times 1 plus 10 times 3. And then 15 times 4 plus 10 times 3. And list those three values. Does anybody have those three solutions? How does everybody have?
45, 60.
And then the last one you said was 90, correct? Yeah. So it wants us to find the max, which we now know this one is the max value. That happens at 4, 3. The first one is the min, and that happens at 1 and 4.5. So that would have been a full problem that you would have done last night. Any questions? With that? The first and second solutions are switched.
Yeah.
Oh, because I have them opposite. Okay. Thanks, Odette. So this one should be 45 and this one is 60. So there's our max. Nope. Here we go. Thanks, Odette. So just to quickly kind of go through number 6, because there were a good number of questions on number 6. If you just look at your homework. So number 6 from the homework. And this was the book problem. Gave you 4 inequalities to graph. And those 4 inequalities started with x being greater than or equal to 0, y is greater than or equal to negative 2, y is greater than negative x, and then x minus 4y is less than or equal to 16. So 3 of them already have the variable by itself. That last one we'll have to get by itself. So the first one, x is greater than or equal to 0. X is a vertical line. So vertical line at 0. Greater than or equal to means we would be shading to the right. The second one, y is greater than or equal to negative 2. So that's our horizontal line at negative 2. So we know we're in this direction and we're above here. The third line is y is greater than negative x. What's the y-intercept when you have that equation, y is greater than negative x? Abby? 0. So this graph starts at 0. And then, Abby, what's the slope?
1.
A negative 1. Y is greater than negative x has a slope of negative 1. So this should be a decreasing line. And it's also dotted, because it just says greater than. And again, we are above this line. So that's what my graph looks like. So far, if I were to shade, I'd be shading from this diagonal line and then kind of off into the right. The last one we have to solve, so we would take the x to the other side, giving us negative 4y is greater than or equal to negative x minus 16. And then we divide by negative 4. Does anybody have that inequality once you divide by negative 4? What inequality do you get? Julia?
Y is less than or equal to 1/4 x plus
Why'd you flip the sign?
Divided by negative number.
Exactly. So the trick with number 6 here, when you're dividing by a negative, you have to flip the sign. The number that's with x, there's a negative 1 in front of the x on the top. You're dividing by negative 4. So pulling that apart gives us a positive 1/4 and then a positive 4. So when we go to graph this, we're moving down 1 and right 4. And it says less than or equal to. Any questions on that graph? So making sure that you remember to flip the sign. I should have went up 1 and right 4. Darn it! See, this happens. I graphed wrong. I was creating a negative graph. So we're going to have to ignore my 1, 2, 3, 4. Okay. Ignore the pink. There we go. So now we have a graph from this vertical line, and that was at 0. It does connect at 2 locations. It connects down here at the 0, right here. It connects up here, and then it's kind of unbounded on this side. So we have a location at 1, 2. This is 2, negative 2. We have a location at 0 and 4. And then the rest of it is called unbounded because it's just going to get wider and wider forever based off of that top line. So there is actually not a max because there's not a maximum value, not a maximum ordered pair that we can plug into the graph because the graph is just going to go get wider if we could continue to draw the graph out. So 2 vertices there at 2, negative 2 and 0, 4, but there would not be another vertex to find. So that's an unbounded graph. It doesn't have a shape because of the way the lines are going. Questions? So today we're going to do the same exact thing, except we're going to add a little word problem part to it. But our goal would be to kind of think about the same information. So we'll be graphing in the same manner. We'll be finding the places where the graph intersects. But we'll be looking at a word problem. So this is the last little piece to this graphing inequalities, placing an application to it so we actually have something to kind of think about when we're trying to find the max or the min. We talked about an objective function briefly yesterday. This is an equation that's used to find the max or the min. Of the feasible region. Feasible region would be our solution. So the objective function is an equation that we're going to use to find the max or the min of some type of problem application. The corner point principle says the max or the min, or the max and the min, occur at the vertices of the graph. a number in the middle, I would have a point that's in the middle of the graph. But if I want to find a max or a min, the max or min occurs at one of the corner points or one of the vertices. It's actually a little principle somebody created that they kind of noticed that was happening with all the graphs. So we have this big problem here, and you have 2 of them to do tonight. It looks exactly set up like this, so you kind of know what to think about as you're working through the problem. But there's only 2, and I have a skeleton to give you that looks just like this, so you can kind of fill it out as you're working through the problem in the book. A small company makes toys, actually animals for toy stores. They're going to make lions and giraffes. It decides to make no more than 75 animals in all, and to keep the number of giraffes to be no more than 5 more than the number of lions. That's a wordy sentence there. It says, represent the constraints with a system of linear inequalities. So instead of you being given the inequalities, we now have to create them based off of the words, kind of the problem that we're given. When we create constraints or write a system of linear inequalities, you have to first make sure you're defining the variables that you'll be using. And that'll always be the first question that you're asked. What are your variables? What do they represent? In this case, x represents the number of lions, y represents the number of giraffes. So that's already given to you. In the problems that you'll be doing, you'll have to make sure that you say x represents this piece, the y represents that piece of the problem. So we need to come up with some constraints, which are really inequalities. That's another way of saying write inequalities for the system. So if you go back, read the question a second time. Maybe just start with the first sentence, start with the second, again, go to the second. Is there an inequality that we can create from the first sentence? If not, move to the second sentence. So the first sentence is more informational. Looking at the second sentence, is there an inequality that we can create using the information in the second sentence? Just the first half of the second sentence. It decides to make no more than 75 animals in all. So how could we write an inequality to represent that, Gavin? Yeah, x plus y is less than or equal to 75. So that's this part here. We have 2 animals that they're creating, the lion and the giraffe. I probably would have picked the elephants and the monkeys, but we got lions and giraffes instead, which are very nice to look at the zoo. I like the elephants. The second part says, and to keep the number of giraffes to no more than 5 more than the number of lions. That part's a little confusing. So in that information, they're talking about an inequality symbol, no more than, and then we're also talking about a restriction, 5 more than the number of lions. So think about how would that look if you're creating an inequality? 5 more than the number of lions. Anybody know how that one would be created? What would that look like? Matthew?
Y is less than or equal to x plus 5.
Perfect. So x plus 5, x is lions. 5 more than lions. So here's my lions plus 5. So 5 more than lions is the part on the right. No more than means my number of giraffes has to be less than or equal to that. It can't be more than that. It has to be less than, or it could be equal to the value. So there are actually 2 more inequalities that we need to write that aren't given in the problem. And they're kind of called assumed inequalities, even though we don't like to assume in math. Does anybody know the other 2 inequalities that we would have to place on this? Julia, do you know?
X is greater than or equal to 0, y is greater than or equal to 0.
Why do you say those 2?
They're making toys, it's either they have none or they have.
Yeah. So because we're actually now making something in real life, we're making toys, lions and giraffes, you can't make a negative number of items. So those are kind of like the assumed ones that are in the problem based off of the fact that we now have an application that we're actually making something. They need to be listed in every single problem because we have to restrict it to a positive number. Any questions with creating this? So it says graph the feasible region and find the coordinates of the vertices, record these below. Because our graph is positive, I'm just going to go over 2 boxes and make my y-axis. And I'll go up 2 and make the x. We don't have to put it in the center because it has to be greater than or equal to 0. So I just went up 2 and over 2 to give us more of a graph to use. That way I have the whole graph to look at instead of just half of it. So again, x and y being greater than or equal to 0. So y greater than or equal to 0, x greater than or equal to 0. We have to count up to 75, which you're not going to have 75 boxes to use. What do you think would be a good number to count by? 5, yeah, let's count by 5s. And whatever you count by, use the same amount on your x and y axis. That keeps both of them congruent to each other. So each line we're going to have to use 5s. So no longer are we just dealing with values that go up to 10, we're now looking at values that go up to 75. And we know that the x would be the number of x lions, yep. So the x-axis represents our lions, the y-axis represents the giraffes. So a little bit more extra labeling going on because it's talking about lions and giraffes. We have what the x and the y represent. So now when you graph, the first one just goes up to 5, and we have a positive x value. So we're going to go to where y is 5. And then you're still going up 1 over 1 because we counted each by 5. So if I go up 1 over 1, really I went up 5 over 5, but that's still 1. 5 over 5 is still 1. So because we kept each of the lines consistent, each of the axes consistent, we can still use the same slope, up 1 over 1. The second inequality says y is less than or equal to negative x plus 75. So that one goes all the way to the top at 75. And now we're going down 1 because it's a slope of negative 1. Make sure you're noticing where those two lines connect and then where it connects with the x-axis. Almost a triangle, not quite, because on the left side we have this vertical little spot where it goes with the y-axis. So now we have our graph. List the 4 corner points, because then those 4 corner points are going to be used to answer the last question below. So we have 0, 0. And 0, 5. Those are the 2 points that are on the y-axis. They meet in the middle, and that number it looks like is 35, 40. And then the final ordered pair is when it's touching the x-axis at 75, 0. So I just looked at my graph, I got those 4 points where they were meeting, the 4 points they connected with another line. The last question underneath says use the profit equation on each lion is $20 and the profit of each giraffe is $18. How many of each kind of animal should the company make to have a maximum profit? So we want our profit to be $20 on a lion, which means we're earning $20 for every lion we sell, and $18 for every giraffe. So if you take your 4 ordered pairs and plug them into the equation, which one of those is going to give us a maximum profit? Obviously, the one with 0 would not be a good one to make, unless we didn't want to make any money. Even the one with 0, 5. Maybe making 35 and 40 would be work for us, give us a maximum profit, or possibly just making lions and forgetting about the poor giraffes. So see if you can make those calculations, determine which one of those gives us a maximum profit. So Brand, how many animals should they make?
75.
Yeah, they should make 75 lions. Should skip the giraffes. Poor giraffes, they're pretty to look at. Because the max profit occurs when you make 75 lions. So your homework, I have a skeleton for you. So if you look at the front, you got one problem. I take you step by step, exactly like the problem we just went through. You look at the back, there's another problem, step by step, exactly like the problem we just went through. You need another one. So it's on page 176 of your book. There are 2 problems. Fill in the front, use this kind of like notes. Look at the notes as a reference if you need to kind of refer to them. And then there's a back, 2 problems to make. Anybody get the book to work? Yes?
Yeah.
Good, awesome.
You have to use photon though.
Yes, you're right, you have to use photon. Yeah, I should have said that. Yes, that lovely photon.